Hello everyone. I Lavendra welcome you all in the another chapter. And from today onward, I am going to start a fresh chapter, motion in a straight line. So let's begin. So motion in a straight line means when object move rectilinearly, right? So it can move either in length or in width or in height only, something like this. Okay. So first, let's understand what is meant by motion in physics. Let's consider an example. Let's say there is a car and it is moving and one observer is observing this. So in terms of physics, I would say the position of the car is changing with respect to its surrounding. That's why the car is in motion. So the definition of motion is a body is said to be in motion when it changes its position with respect to its surrounding. Okay. So this needle is moving. So can I say it is in motion? Definitely yes. So yes, the position of the hands of the clock change continuously. So yes, this hand is in motion. Can I say this water is in motion? Again, the position is changing. That's why I can shortly say the water is in motion. And what about our Earth? So obviously Earth position is also changing. So yes, it is also in motion. Now, what is rest? So again, consider an example. This time our car is waiting on the signal. Okay. So now in this case, the car is not changing its position with respect to its surrounding, right? The position of the car is not changing with respect to its surrounding. So yes, I can say the car is in rest. A body is said to be at rest when it does not change its position with respect to its surrounding. Okay. Now motion is relative. How? For example, if you see this Statue of Liberty, then according to you, it is in rest, right? But what about an alien? Okay. So since Statue of Liberty is on the earth and since our earth is rotating, so definitely Statue of Liberty is in motion in comparison to alien ship, right? So one thing can be in rest for one observer and for another observer it can be in motion. That's why I would say motion is relative. Motion depends on observer. That's why motion is relative. Okay. Now let's understand point object. So in this scenario, you can see a horse is participating in a race, right? So let's suppose the distance between the track is 1000 meter, while the overall length of the horse is 2 meter, right? So anything can be a point object. Anything can be a point object if the dimension of that object are negligible compared to range of the motion involved. So in this case, 2 meter roughly has significant value in comparison to 1000 meter. So in this case, I can't consider this horse as a point mass, right? Okay. Now what is a particle? So a particle is an object which has a negligible dimension. Okay. And what is rigid body? So rigid body is a combination of particles, and when an external force is applied, there will be no change in its dimension. Generally, all solid object can be considered as a rigid body because if you applied force on it, it will not change its shape generally. Okay. So one question may be arise in your mind that whether we are particle or a rigid body, right? So in physics, its answer depends on situation. Okay. So for example, relative distance is less. If relative distance is less, then you will be considered as a body. Now let's consider that someone is in plane and somehow he is watching a small child who is on the planet Earth. Now, in this case, the distance between the two person is very large. So in this case, we are going to consider this person as a particle. Okay. So now again, if distance is very much large, we treat object as a particle, or if distance is somehow less, in that case we consider as rigid body. So particle and rigid body are relative terms. Okay, now let's try some questions. A particle is an object having negligible, and your options are units, dimensions, magnitude, and direction. So a particle is one having a negligible dimension. Just now I taught you this. Now the second question is, rigid body is a combination of particles, and when external force is applied, there will no change in its, and your options are magnitude, dimensions, magnitude and directions alone. So if you applied force, then dimension of the rigid body do not change. Next, rest and motion are dash term. So absolute term, no. Not absolute, yeah, it can be the answer. Relative term, yeah, this is again correct. And option D is both B and C. So obviously both B and C, option D is the correct answer. Types of motion. So according to dimension, there can be three types of motion. First motion is known as linear motion. Okay. Second one is 2D motion or two-dimensional motion. And third one is 3D or 3D or three-dimensional motion. For example, if a bullet is fired towards you, then the motion of the bullet is 1D motion. If you throw a ball is in upward direction or in downward direction, in both case it is 1D motion. If I'm talking about some examples of 2D motion, so it is going to be projectile motion is a 2D motion, while circular motion is also a 2D motion. Now let's talk about 3D motion. So if a mosquito is roaming in your room, then it is an example of 3D motion, or the motion of gas particles are also an example of 3D motion. How many types of motion are there? So just now I taught you 2, 4, 3, and 1. So obviously 3 types of motion are there. Next, motion in one dimension is also called motion in space. No. Motion in a plane. No. Motion in a plane is 2D motion. Motion in a straight line. Yes. Motion in a straight line is one dimensional motion. And motion under gravity. Motion under gravity can be one dimensional or two dimensional. Okay. Projectile motion can be treated as a motion under gravity. So option C would be the correct answer. Okay. Now types of particles motion. Motion can be of vibratory, rectilinear, curvilinear. Now based upon particle motion, motion can be vibratory, rectilinear or straight line motion, curvilinear motion, oscillatory motion, circular motion, or rotatory motion. So all these kinds of motion we are going to learn in near future. So just be with me. Let's understand the concept of distance and displacement. First of all, distance means actual path length covered by a body, while displacement means shortest distance between initial and final position. Okay, so let's understand. So I am going to start from a point A. Let's say there is an athlete, and A is the initial point, and B is considered as a final point. Okay, so one athlete is running in this way, as you can see here. Now, she reached on point B. So the overall distance is covered by her is 250 meter. So obviously distance is going to be 250 meter, right? Now, let's suppose the shortest distance between A and B is 160 meter. So this 160 meter is going to be displacement, because again, this is the shortest distance possible between A and B. So A and B is the displacement. Now, what about if this athlete complete one round? Okay, so if this athlete complete one round, obviously the distance covered by her is going to be 500 meter, while displacement is going to be 0, because obviously shortest distance this time is 0. So that's how we can formulate a table using this data. So from A to B, distance is 250 meter while displacement is 160. And from A to A, distance is 500 meter. And the question is, in this given figure, object starts its motion from point A, okay, and goes A to B, B to C, C to D, and again come back to the point A. Now the distance at point A we need to determine. So I have already discussed distance is going to be the actual path covered by the body. In this case, this is going to be 16 meter. Next question. Again, the same question. Person is going from A to B, B to C, C to D, but D to A. And in this case, we need to determine displacement. So initial point and final point is same. That's why displacement is 0 here. Next question. Vectors are physical quantity which possesses. So from the earlier chapter, we already know vectors has magnitude and direction both. When a athlete run on a circular track and reaches the same point, so if he or she reach the same point, then distance is not 0. Distance will have certain value, but displacement is 0, right? So displacement must be less than distance. So option B is going to be the correct. Displacement is a dash quantity. So we already know displacement is a vector quantity. It requires direction. The numerical ratio of displacement to distance is, and your options are always less than 1, always greater than 1, always equal to 1, maybe less than 1 or equal to 1. Okay. So let's figure out its answer. So they were interested in numerical ratio of displacement versus distance. So we have already learned that displacement in most of the case is less than distance. It can be equal to distance, but it cannot be greater than distance. So this ratio either is less than 1 or it can be equal to 1. So that's why option 4 is going to be the correct of this question. So as you can see, the option 4 is going to be the answer. The question is, a boy travel 4 meter in north. Okay. So a boy travel 4 meter in north and 3 meter in east. Okay. 3 meter in east. Then we need to determine its distance. So distance means the actual path covered by the body. In this case, person travel 4 meter plus 3 meter. So overall distance is going to be 7 meter, and that would be the answer. The question is, calculate the magnitude of displacement when a body is moving along the indicated path. Okay, so displacement I need to determine. So if you watch closely, you can shortly say this person has traveled 2L distance in X direction while L distance in Y direction. And displacement means shortest distance between initial and final point. So this distance can be considered as a displacement. So hypotenuse I need to determine. This angle is 90 degree. So I can remember Pythagoras uncle. Pythagoras uncle has told us hypotenuse ka square or hypotenuse square equal to base square plus perpendicular square. So hypotenuse square is going to be 4L square plus L square, or else 5L square, or else under root of 5L square. So under root 5L is going to be the displacement. So that would be your answer. In this question, the question is asking, a person first moves 3 meter east, okay, then 4 meter north, okay, and finally 5 meter up, or you can say in positive y direction. Determine the displacement from the starting point. Okay, so displacement I need to determine. So first I am going to determine its displacement vector. Okay, Balapom. So now let's talk about its displacement vector. So it is going to be 3I because it is moving in 3 meter east, then 4 meter north. So 4J, and lastly 5 meter up. So plus 5K. Okay, now displacement vector. So using this displacement vector, I can determine its magnitude, and that magnitude is actually my displacement. So if you solve this, you will get 3 square 9, 4 square 16, 5 square 25. And if you add all of them, you will get under root 50, which is nothing but 2 into 25 or else 5 root 2 meter. So that would be your answer. Next question. Okay, so this time the question is a person moved 3 meter east, then 4 meter north, and finally 5 root 2 meter in the southwest direction. Calculate the displacement from the starting point. Okay, so this time again I need to determine what displacement. Okay, so first I'm going to write displacement vector. So in this case, initially the person is moving 3 meter east. Okay, so 3 meter east, so 3i. Then 4 meter north, so 4j. And 5 root 2 meter in southwest. Okay, so let me draw southwest. This is my north, this is south, this is east, this is west. So person is moving 5 root 2 meter in southwest direction. Okay, so somehow person is moving in this way. This angle is going to be 45 degree. Everyone know this fact, right? And this distance is given to me as 5 root 2. Now, let's figure out its components. So, the side with angle is 5 root 2 cos 45 degree. We already know this. And the component part, which is without the angle, is come with sine value. So 5 root 2 sine 45 degree. So if you solve this, you will get 5. And similarly here again you will get 5, but this is in minus I while this is in minus j. Okay. So now I am adding these two vector also. So now I have 5 times of minus I plus 5 times of minus j. Okay, sir. Now I need to solve this. Yeah, definitely you need to solve this, my child. So, sir, 3i plus 4j minus 5i minus 5j. So now the answer is going, sorry, now the position vector, or you can say displacement vector, is going to be minus ka 2i minus ka j, or the value of displacement is going to be minus 2 square plus minus 1 square, or else it is 4 plus 1 under root 5 meter. So that would be your displacement. Next question. A particle goes from 3i plus 4j to 5i plus 7j. Calculate the displacement between these two positions. So this is my R initial, this one is my R final, and I need to determine its displacement value. So R initial is given to me as 3i plus 4j, while R final is given to me as 5i plus 7j. Now, what I need to determine? I need to determine position vector. So it is going to be R final minus R initial. So R final is 5i plus 7j minus R initial is minus 3i plus 4j. Now, let's solve this. So 5i minus 3j, this will bring 2i plus 7i minus 4j. So this will get plus 3j. So this is going to be my my position vector, and the value of displacement is going to be under root of 2 square plus 3 square. So 2 square is 4, 3 square is 9. So under root 13 unit is the displacement, while displacement vector is 2i plus 3j. Next question on your screen is this one. The question is, determine the displacement of the tip of the second hand of a clock in 30 second, 15 second, and a theta angle term. The length of the second hand is denoted by R. Okay, denoted by R. So in this case, they have given a clock, right? So in first part, in 30 seconds, so the needle is of second hand needle. So in 30 seconds, it will complete half of its journey. So somehow it will look like this. Initially, the needle may be pointed in this direction, and after 30 seconds, its direction will change, or you can say it will cover half distance. So its final position will look like this. Now, in this case, they were asking the overall displacement. So displacement means shortest distance between initial and final point. So this is my initial point, this is my final point, and this it cover 180-degree angle. So in this case, the shortest distance between them is going to be 2r. So displacement would be 2r because r is the length of this second hand needle. Now second part. So in second part, the needle is completing only 15 seconds, right? Only 15 seconds. So in 15 seconds, the needle will point somehow in this direction, right? So again, I need to determine its displacement. So this side is R, this side is R, this angle is 90-degree, right? So this thing is going to be the displacement, and this length value I need to determine. So obviously Pythagoras will definitely help me. So if I consider this as h, so now what Pythagoras uncle has said, so hypotenuse square is equal to base square plus perpendicular square, or else hypotenuse square equal to 2r square. Hypotenuse is going to equal this much, or else under root 2r. So this would be the value of my displacement. So under root 2r is going to be the answer for second part. But sir, what about its third part, which is the tough one, right? Our needle is making angle theta uh, with, in third case, our needle is making angle theta. This side is given to me as r, while this one is also r. So obviously this length is going to be my displacement, and that is being asked. So in this case, the direct result is 2r sine theta by 2. So that is going to be the answer. Next question. The question is, a person moves in a circle of radius small r. He completes 3 by 4 of the revolution. Find the distance and displacement of the person from his starting point. Okay, Sarji. So now let's try. There is a circular track on which a person is moving, and he complete 3 by 4th part of it, right? So radius is already given as small r. So radius is already given as small r. So this one is going to be 1/4 part. This one is going to be 2/4 part, and it is going to be 3/4 part. Radius is given to me r. So let's say person is running in this manner. So once he reach on this point, he has covered 1/4 part, here 2/4, and here 3/4. So finally, the person has reached this position. Okay, this position. So this is my initial point. This is my final point, and radius is given to me as small r. So first I am going to answer its distance part. So distance is going to be this much length. This much length is going to be the distance wala part, right? Okay. So for this, I need to use arc length formula, and that was 2 pi r into theta upon 360-degree. Obviously, this angle is going to be 270-degree, right? This angle is going to be 270-degree. So instead of theta, I am putting 270-degree. So 270 upon 360. 0, 0 get cancelled. 9 3s are 27. 9 4s are 36. 2 2s are 4. So eventually I am getting 3 pi r upon 2 as my distance. Now, in this second part, they were interested in displacement. Okay, so let's figure out its displacement. So this length is going to be its displacement, because obviously this is the shortest part. shortest part, because obviously this is the shortest distance. Okay, now let's determine displacement. So for displacement, I need to use Pythagoras theorem. And if you use Pythagoras theorem, this side is R, this one is R, and this angle is 90 degree. You can try at your own. So this height you will get as, sorry, this distance you will get as R root 2. So directly I am writing displacement is R root 2. The question is, on an open ground, a person follow a track that turn to his left by an angle of 60 degree after every 100 meter starting from a given turn. Find the displacement of the person at third and sixth turn. Okay, so let's try this one. So a person follow a track which turn at 60 degree after every 100 meter. Okay, so the track will look like this, as you can see here. Okay, the track will look like this. Now the person follow this. The person starts from here. So first turn, second, third, fourth, fifth, and sixth. So after sixth turn, the person reach at its initial point. So after sixth turn, his displacement must be 0. Now let's figure out displacement after third turn. So first, second, third. As you can see, the person is turning 60 degree after covering 100 meter in each direction. Okay, so that's how he is following this path. Now, so after third turn, according to me, this thing is going to be the displacement. Okay, this yellow line length I need to determine. This is 100 meter. This is again 100 meter. This one is also 100 meter. So this length I am considering as x, and this is I need to determine. So for this, to figure out the value of x, I am drawing a perpendicular over here. If this angle is 60 degree, this one is also going to be 60 degree because of corresponding angle. As you can see here, that this line is parallel to this one. So these two angles are corresponding angle. Okay. Now, if you follow this triangle and use cos theta here, or I can say cos 60, which is base upon hypotenuse. So 100 upon x, cos 60 is 1 by 2. So 1 by 2 equals to 100 upon x. The value of x is going to be 200 meter. So after third term, displacement is 200 meter. After sixth term, it is 0 meter. Option D would be the correct answer. Now let's consider some basic definition. Now let's consider speed and velocity. So speed can be defined as the distance covered per unit time is known as speed. So the formula for speed is going to be distance upon time, or delta d upon delta t, while velocity, the rate of change of position in a given direction, is known as velocity. So this is going to be the definition. Formula for velocity is going to be displacement upon time, or delta s over delta t. Velocity is a vector quantity, we already know, and SI unit of velocity is meter per second. Displacement, sorry, speed is a scalar quantity and its unit is meter per second. Okay, if I am talking about its types, right? So speed and velocity, if you classify it based on time, it is of two types: average speed or average velocity, or instantaneous speed or instantaneous velocity. According to distance covered or displacement covered, it is again of two types: uniform speed or uniform velocity, non-uniform speed and non-uniform velocity. In uniform speed, object cover equal distance in equal time. In non-uniform speed, object cover unequal distance in equal time. Average speed means total distance upon total time, while instantaneous speed is the speed of an instant. Okay, so let's understand each one of them. Perform an activity. Amar, Akbar, and Anthony are traveling by their own car. Let us understand whose car is moving with uniform motion. So that I need to figure out. So we have three candidates: Amar, Akbar, and Anthony, and they are using their car. And the table is given to me. Time is already given, and gap, as you can see, is 30 minutes in each case. Now, distance covered by Amar is given in this table. So obviously, Amar is going with uniform speed. In equal time, he is covering equal distance. Now, what about Akbar? So table for Akbar is this much, but here, as you can see, Akbar is not covering same distance. That's why Akbar is moving with non-uniform speed. Last, Anthony. So this time the gap is again 14. So Anthony is also going with uniform speed, right?